What's that?
The telescoping?
Yeah, isn't that funny? Telescoping will be gone forever. Okay. Hey, let me give you this. So we're going to do direct comparison test, and then we'll do telescoping. 2, 3, 4. And I guess, well, you're going to pass that last one down, all the way down to Zach. 1, 2, 3. Kylie, did you find a place to have your club meeting?
Oh, no, we just canceled.
Oh, I'm so sorry. I felt really bad.
It's okay. We asked like every teacher that we've ever had, and like no one was available. It was actually funny.
See, ordinarily, it would have been no big deal. Honestly, ordinarily.
That's what everyone said.
Yeah. Also, it was tough for me because I was giving like a bunch of late tests, and it was going to be hard to have a club meeting and to tell you guys, now be quiet because I have kids taking exams. But that doesn't happen very often with me either. So I don't know, next time give me a try. Maybe I can help you out.
Oh, we did this yesterday in Horse.
What's that? Okay. Oh, and you started the tape, so we wasted a precious minute. Okay. Here comes direct comparison test. You got the sheet in front of you? We're going to learn this in 5 minutes, baby. Direct comparison test. Let the series of interest be the sum of a sub n. To prove convergence, find another series b sub n such that every term of a sub n is less than its corresponding term for b sub n, and b sub n converges. Someone tell me, how would that prove that a sub n converges if you find another series that you know converges and every term of a sub n is less than its corresponding term of b sub n? How would that show that a sub n converges? Yes?
But kind of like the thing that we used on the homework where it gets one P series is bigger than the other P series, so subtractively, you must have both have finite numbers.
Yeah, that sort of thing, yeah, sure. Okay. Are you guys okay with this idea that if one series, essentially what they're saying, if one series converges and the other series is smaller than the one that converges, then the other series must converge as well?
Oh, yeah.
That's all they're saying, you know? And so look at the next one, to prove divergence. If I want to prove a sub n diverges, then I'm going to have to find a b sub n that diverges. And what's going to have to be the relationship between a sub n and b sub n if I want a sub n to be proven to diverge?
It needs to be bigger.
Yeah, it needs to be bigger. Absolutely. And that's all direct comparison is. You're taking your series and comparing it to something that you know converges or diverges. And thus, from that comparison, you can make your conclusion. Hey, let's do a couple of examples. Look at example number 1. I want the series 1 over 3 to the power of n plus, 1 over 3 to the n plus 2, okay? 1 over 3 to the n plus 2. I want to see if that converges or diverges. Well, step 1 says, find a geometric or p-series similar to a sub n. And then you ask yourself, does it converge or diverge? You call that b sub n. So because I've got this series a sub n, you know, my series is going to be 1 over 3 to the n plus 2. I hope you ask yourself, is there a series similar to that that's really, really simple? And the answer is yeah. Yeah, the series that's similar to that that's really, really simple is 1 over 3 to the n. And tell me, what kind of series is 1 over 3 to the n? And by the way, we've only learned about the convergence of 2 types of series, p-series and geometric series. What kind of series is that?
Geometrics.
Yeah, it's a geometric series, right? This is a geometric series, and tell me, what's my r?
3. 1/3.
1/3. My r is 1/3. So I found this guy is, I assume, going to be similar to this guy. And I know this guy converges because r is between -1 and +1. And then step 2, do a term-by-term comparison. Do you see, I actually just plug in 1, 2, and 3 and compare the terms. And do you see, every term of my a sub n is less than the corresponding term of b sub n? 1/5 is less than 1/3, 1/11 is less than 1/9, 1/29 is less than 1/27. Then step 3, I do my conclusion. And I want your conclusion to be of that form, because the sum of 1 over 3 to the n converges, and 0 is less than or equal to 1 to the 3 to the n plus 2, you know, a sub n is less than or equal to b sub n, then my a sub n converges as well. Hey, let's do another one. Let's do example number 2. Just a second. Here, example number 2. I got the sum as n goes from 2 to infinity of 1 over n minus 1. What? Oops. What's a really simple series that this is going to be similar to?
1 over n.
How many people think of 1 over n? Yay for you guys. Okay, so I'm going to let my b sub n be 1 over n. And tell me, does that series converge or diverge? It's the harmonic series. It's your borderline series. Does the harmonic series converge or diverge?
Diverge.
It diverges. It's a p series where p is less than or equal to 1. So this is a divergent p series. It diverges because p is less than or equal to 1. We prove that by repeated use of the integral test. Okay, so now I've got my a sub n, okay, which is the sum as n goes from 2 to infinity of 1 over n minus 1. I've got my b sub n, which is the sum as n goes from 2 to infinity of 1 over n. Now I'm going to do a term-by-term comparison. Okay? Here, let's write it out. Stick in a 2, I get 1. Stick in a 3, I get a half. Stick in a 4, I get 1/3, and so on. Let's do it for b sub n. Stick in a 2 and I get 1/2. Stick in a 3 and I get 1/3. Stick in a 4, I get 1/4, etc. What do you notice about the terms of these guys versus the terms of these guys?
They're bigger.
Yeah, this guy diverges, and this guy is bigger still, correct? This guy adds up to infinity, and this guy, every single corresponding term is bigger than this guy. So if he adds up to infinity, certainly this guy adds up to infinity. And so now we get to do our conclusion, and our conclusion is going to look like this. Because the sum as n goes from 2 to infinity of 1 over n diverges, and 0 is less than or equal to 1 over n minus 1, which is less than or equal to 1 over n, I get to conclude that the sum as n goes from 2 to infinity of 1 over n minus 1 converges also.
Diverges.
I'm sorry, diverges also. Thank you. Thank you, Andrew.
Oh.
What's this?
Um.
Oh, I went the wrong way. Oh my God.
Yeah.
I'm so stupid. Jawad, what did I do wrong?
You just switched the terms.
Yeah. God, I don't know what my problem is. This guy is bigger than this guy. Yeah. You need to make sure, boy, I would have taken points off myself. If I make that mistake on an exam, I do lose points. Because it's really important that you know, if you're going to show that this guy diverges, these guys have to be bigger than those guys. I just lost points on my exam. I just got an F.
I don't think it's that serious. It's 1 point.
That's the serious. Okay, you guys ready to do it on your own? Okay, here we go. Example number 3. I'm going to make up a new example before I have you do this example here. Okay? The sum as n goes from 1 to infinity of 4 to the n over 3 to the n minus 1. Step one, you've got to choose, this is your A sub n. You've got to choose a B sub n that's going to be really similar to that. And then you've got to decide if it converges or diverges. Yes? Sure. Take a roll. By now, you should have chosen your B sub n. What did you choose as your B sub n?
4/3 n.
How many people chose 4/3 of n power? Okay, good for you. And tell me, does this guy converge or diverge?
Diverge.
Good. Now go ahead and do a term by term comparison. Yes. What's that? Yes. 4 to the n over 3 to the n. I know that as n gets bigger and bigger, that 1 becomes insignificant. So I know that as n gets really big, this guy is going to act like just 4 to the n over 3 to the n. So that's one way to do it. Another way was just to visually look at it and go, you know, that's going to look a lot like just 4 to the n over 3 to the n, ignoring the 1. You know, just intuitively. Well, that's 2 as well, isn't it? Okay, did everyone successfully write out a term-by-term comparison? And did you notice every term of this guy is going to be bigger than every term of that guy? Because the denominator's smaller. The numerators are the same, but the denominators are smaller, which means this guy's bigger. And that's what we want, because we're trying to prove divergence, right? I mean, if we think this guy is going to act like this guy and this guy diverges, we want to show that this guy diverges. So these guys better be bigger than these guys, or I'm going to have to choose another B sub n. You see? But it happened for us, and so now we get to do our conclusion, and we get to say because the sum of 4 to the n over 3 to the n diverges, and 0 is less than or equal to